For this homework, we set out to make an algorithm that can use a computer webcam to automatically detect the presence of someone or something that has entered a user-defined area. Here is the setup that I used for my assignment. The detection pipeline is as follows. Our detection pipeline starts with an algorithm taking two images 0.25 seconds apart. The algorithm then writes those images to file. These images will be stored in the same file directory as the code file. Then, we will read the image into the code before masking, blurring, and converting the image to grayscale. To perform all these alterations, we must create a user-defined script. The script will require an image as an input and create a mask using a zero array, convex poly, and a bitwise AND operation. It will then take that masked image and convert it to grayscale using the BGR to gray CV2 function. After that, it will blur the image using a Gaussian blur function of a specified kernel size. The function takes one input and returns the masked and grayscaled images. The script will then write the masked and gray images to files named gray1 and gray2, as well as masked1 and masked2. After that, the code will go through every pixel of the grayscaled image and return the value of it as a number between 0 and 255. It will compare the difference in the pixels in the two images, and if their values are different by more than a certain number, then they set the value of that pixel to 255 in a zero array that I previously defined. Once that array was appended, I summed the array and divided the sum by 255 so that we would obtain the exact number of pixels that were different enough from the first image and the second image. I stored that value in a variable called detector total, and I printed that value to the terminal to let me better experiment with detection thresholds. If the value of the detector total was higher than my set detector threshold, then the code was triggered to start a recording with the name of the current timestamp. Since my camera records at 30 FPS, in order to record a 30-second clip, I needed to use a for loop to capture 900 frames and then write that to an MP4 file. I used CV2 Video Writer in order to do this. After that, I used Yagmail in order to send myself a notification email with the subject line as the timestamp and the contents of the email containing the two images and the 30-second video file. Here is the live implementation of my algorithm, and I documented the whole live feed of what my computer was seeing, along with showing you that I received the email notification from the system. For my specific setting, I needed to experiment with different settings and change different things in order to get a better performance from my algorithm. Some things that I had to change were the kernel size of the Gaussian blur, the time threshold between images, the pixel threshold for the grayscale value, and the detection threshold, total threshold. It took a lot of experimentation, but I settled on values that worked for me. For the kernel size, I found that 13 worked well in order to accurately filter out the noise without sacrificing too much image quality. Luckily, my bedroom is a pretty neutral environment, so there was not much noise really to begin with. For the time delay between images, I found that 0.25 seconds works pretty well. Through a lot of experimentation, I found that I can escape detection by moving quickly enough through the frame in under 0.25 seconds. If I set the time between 0.25 seconds, it was virtually impossible for me to move through the frames undetected. For the pixel threshold, I found that 30 worked well to determine motion in front of the camera. My camera has a pretty high resolution, so I could afford to decrease it from the default value of 50. It created a much narrower threshold for the pixels to change. For the detector threshold, I found that 0.1% of the pixels changing is a necessary threshold for detection. Therefore, since my resized frame is scaled down from 1280 by 720 to 400 by 225, the total amount of pixels detected would be around 90,000. If 90 of those pixels are different between the two images, then enough change has occurred to detect motion. This was also a good enough threshold to filter out any noise that it made it past the Gaussian blur. 90 sounds like a relatively small number of pixels, but for my algorithm, it consistently read 0 for the detection total when there was no movement or impedance in the frame. Then, when I barely introduced something in the frame, like the edge of my hand, I could never really change the image by less than 150 pixels. Some improvements that I might suggest for this algorithm are maybe using a camera with higher resolution to better detect motion and better detail. My algorithm doesn't really work with bad lighting conditions, so we could incorporate some sort of infrared camera to alleviate this problem. You could also use an external microcontroller to reduce the amount of processing load put onto the computer. I experienced some lag from my computer in terms of sending an email. In terms of software, you could add some facial recognition or object detection in order to define to the user what the algorithm detected in the first place in its frames.